depending on wherever you've joined us from here today. My name is Shreyas. I'll be your trainer for this particular training. I have over uh, almost 11 years now of experience in teaching Azure-based courses and Databricks, Terraform, all these Kubernetes. So I've been conducting trainings for NICIT Academy, and I've trained almost more than 70,000 students as of now. So I welcome all of you to this particular training session on Azure Databricks. All right. So our entire discussion for today's call is going to be on the introduction of what you can expect from this course. All right. That is going to be the primary area for us to discuss today. But apart from that, we'll also be seeing a lot of other things, especially related to what is the prerequisite, what you should know already, what to keep in mind, why to learn Databricks, what is Databricks, right? What opportunity it brings for you. So all of that discussion we'll have in today's demo session. And the demo session will also continue for tomorrow and I guess day after, where we'll be covering various aspects. So you'll just have a real life experience of what it will be like sitting in the class and trying to understand the various concepts around Databricks, right? So that is what we are going to do for you. Now, before I move further, let me quickly guide you on what to expect from this course and what are the things that we are going to actually cover, right? So this is a course plan for all of you to look at. We'll be having 9:30 to 10:30 p.m. classes every day. The total duration on Databricks will be 25 hours plus. All right. I've written plus because depending on the class, depending on the students, yes, sometimes we move quick, sometimes we have to be slow, sometimes we have to be, in pace with the learning pace of the students. So therefore, at least 25 hours, it can go up until 30, 34, 35 also if required. All right. I'm not saying it will be, but if required, if we want to do more in the class, and that totally depends on the students, on you guys who are going to be a part of this class, right? The more interactive you are, the more questions you ask, the more we work on, and obviously the session duration, it definitely goes beyond. Now, apart from going around talking about Databricks and what it is, how it uses the Spark architecture or the Spark, programming, PySpark programming, how you're going to use that, what are the various features within Databricks. Apart from discussing all of that, since this course is called Azure Databricks and not Databricks in general, right? Because what I'm going to teach you in these 25 plus hours is going to be how you make use of Databricks and its capabilities within the Azure platform. Correct? Now, I'm not sure if all of you have an understanding on what Azure it is. All right, what is Azure, right? Maybe most of you are new to cloud computing, so you may not have an idea about cloud computing from scratch. Some of you may have an idea about cloud computing, but that could be relevant to AWS or GCP or some other cloud that you've been working with, right? So we'll have initially a 5 hour session, right? That means a week's time will be spent on understanding Azure. All right. And this is where we need to take a look at various services that we are going to cover in Databricks also. For example, when working with Databricks, we need to work with the Azure Data Lake Storage, right? Until and unless you understand what Azure Data Lake Storage is, how you create Azure Data Lake Storage, it will not make any sense to you why we are integrating data lake, why we are mounting data lake, all those scenarios. To understand them properly, you need to have a solid understanding of the Azure platform also. If not all the services, the required services at least. Now, coming to the required services, we need to understand a virtual machine, right? My Databricks environment will create within my Azure subscription, which will work as the compute. We need to know what is data lake storage. We need to know what are the databases available, and then how do I connect my Databricks environment to my Azure environment. All right, because they are not unified. Even though they are connected, they are managed, but Databricks is a separate environment, Azure is a separate environment. And when I want to mix the two, there has to be some proper permissions and access control that needs to be granted to my Databricks environment, right? So that it can connect to Azure and fetch data from there, or work on data from there, or work with various data stores that we are going to create. So that is where our 5 hours bonus lectures on Azure will come in. I will explain you cloud computing from scratch. All right. We'll take a look at what cloud computing is. We'll take a look at what Azure is, how Azure is built, and then the core services that I want everybody to have an idea about, which is mainly going to be the data lake storage. All right, because data lake storage also, and to an extent the data warehouse also, because in Databricks we'll cover something called as a lake house architecture, right? To understand the benefits of lakehouse architecture, first of all, you need to understand what is data lake and what is data warehouse, and what are the benefits of both of them, and what are the shortcomings of both of those things, those services, right? Whether it's a data lake or a data warehouse. Once I understand the pros and the cons, then it'll make more sense, right? When I'm reading about the lakehouse architecture, as to why was there a need to connect the benefits or the pros of data lake with the pros of your data warehouse. All right, whatever shortcomings the data lake has, the data warehouse overcomes that. Whatever shortcomings the data warehouse has, the data lake overcomes that. And that is why Databricks introduced this lakehouse architecture, which most of the organizations today want to use. All right, so that is why we'll have to have some idea about data about Azure in general. Now, in this course, you'll get every day's recorded lecture. All right, so every day we'll complete the lecture at around 10:30 in the night. By early morning tomorrow, or by the next day, you will have the lecture uploaded on the LMS portal that you were seeing a short while ago. All right, on that particular location, you'll find day-wise recording of each class that we have. And on top of that, you will also find all the PDF notes for each of the topic that we are going to cover in this course. All right, so you'll find everything in a unified place on the LMS portal, and the access for you will be available for lifetime. All right, you'll have a lifetime access to all the videos and the learning contents. At the end of the course, we'll be doing two projects. All right, two projects on Databricks, and that will also include some of the Azure based services, right? So that is where I wanted to introduce you to some of the Azure services, right? For example, when we are working with the medallion architecture that talks about creation of bronze, silver, and gold layer, right? Why do we create those layers? What type of transformations are we going to do? And then how do we use the medallion architecture and do a continuous refinement of my data and reach the gold layer? Now, what happens after the gold layer? Where do I put that data? So for that, we'll have a brief discussion on these services that you may have heard about, which is the data factory and the Synapse Analytics. All right, because when you talk about the data engineering, ecosystem, then you cannot limit yourself to a single service. I cannot say that if I know only Databricks, that makes me a good data engineer. If you know Databricks and you know the other services also, and how do they connect to each other, what benefits will Databricks offer you over the other existing services, that is also something that will make you a better data engineer. All right, now throughout this course we'll be writing a lot of code. All right, and primarily this will be Python, and to an extent we'll be using SQL. All right, so that is the only prerequisite that I have for you. You should have a basic understanding of what Python is, right? I'm not asking you to be an expert on Python. Uh, it is my guarantee to all of you that by the end of this course, you would be writing PySpark code fluently. If somebody asks you how to fetch data, how to transform data, how to add new columns, how to rename columns, how to, you know, aggregate the data, all those transformations you would know. All right. They are very easy to understand. Python is a language which is known for its readability and understandability, right? It is very easy to understand. But then again, I need all of your support, where all of you will have to practice, right? Whatever discussions that we are going to have. You need to practice that in real life. And for that, you will be needing an Azure account. And I will guide all of you as to how you can go ahead and create your own free Azure account. All right. Once you create your free Azure account, you can go there, create the Databricks environment. Now, Databricks environment in itself will offer you a free trial version within Azure account. All right. So within an Azure trial account, you can create a trial Databricks account that will give you all the benefits. Now, the Azure account that I'm talking about, all right, it'll give you around $200 of credit, right, which will be valid for 30 days, right? If you want to practice more, even after 30 days, you can go ahead and create a new free account. All right. So that is how you're going to implement the projects also. And that is how you're going to work with this sample code that will be shared with all of you. So I'll be sharing whatever code that we'll be writing in the class, whether it is related to, transformation of data, whether it is related to creation of, let's say, a delta table or doing time travel using delta table, right? Whatever code is to create a database within the Hive meta store, you will get all of this code that you can save as a Python code, and you can refer to it. It is well architectured. I have put all the comments in the code. I have all the headings, the topics, and everything. They are segregated topic wise, right? So you will find it very easy, to work with that particular code base that I'll be sharing with you. All right. On top of that, we'll be sharing the interview questions also and some sample CVs for all of you, right? With the project details added that you can add to your CV to show your experience in working with Databricks. Now, at the end of the course, obviously, you will have a good, all right, or I would say an excellent amount of idea about what Databricks is, what it offers, what all facilities are there, what all features are there, right? Uh, and I'll go through, the content that we are going to cover in these, 30 odd hours that we're going to cover. And these 30 hours will be spread across some, 40, 45 working days, depending on, the number of sessions we have, right? So 45, almost 45 working days, 30 sessions is what we are going to cover. And in these sessions, right, um, as I told you, I'll be coming to the topics, the modules one by one. But you can expect us to cover end to end when it comes to Databricks. All right. There would be no topic untouched, or no particular module untouched. Uh, any question that has been asked to you related to Databricks, right? You'll be able to answer that. That is what we are aiming for. Clear? All right. So now let me introduce you to the tool or the technology that is Databricks, right? So what is Databricks in general, right? What is Databricks? Now, Databricks is a cloud-based analytics platform, all right? And it is built on top of Apache Spark. So that is also something that we'll be covering in the class, right? I'm not just going to tell you what Apache Spark is. We are going to get into the architecture of Apache Spark. What is Apache Spark? What architecture does it use? What is this distributed computing that we are talking about, right? What is the in-memory processing that it gives, which is better than the previous big data analytics platforms like Hadoop, right? What was Hadoop? What was the map reduce function within Hadoop? How is this Apache Spark better than Hadoop? And obviously, Databricks have taken Spark as the core, technology that this entire platform is built around. So we'll try to understand everything. All right. It's not going to be that we are going to only discuss about Databricks. I can open Databricks. I can go on with, Databricks, expecting that you all know what Azure is, expecting you all know what Apache Spark is, right? But that is not something that we're going to do. We are going to cover, first of all, the basics of Azure, then the architecture on which, this platform Databricks is built on, right? The open source distributed computing system, that is Apache Spark. All right. So Databricks is a fully managed service. When we say managed service, most of its tasks, when I say tasks, not the, writing the code and creating the cluster, right? When you create the cluster, you will just define the cluster. The actual creation of cluster, the allocation of resources, the getting of the compute resources and the storage resources, that will all be taken care of by Microsoft Azure. All right, that is why we say it's a managed service. Microsoft Azure is in the background managing the entire platform. So it offers very high performance, right? It offers capabilities for handling your large scale workloads. We'll also try to understand what is big data, first of all, right? The problem that we are trying to solve, right? That is the big data problem, right? What is the big data problem? The three V's, the three V's of big data, the velocity, right? The volume and the variety of data. When I say variety, I'm trying to say that the data is coming in all different, formats from various sources. So that is what we are going to define with variety. The volume, the size of the data, right? And then obviously the velocity, the speed at which the data is getting generated. So therefore, we need systems that can process more and more and more data as quickly as possible. Because today, unlike 20 years ago, we are generating massive amounts of data. It's not even close, right? Of the amount of data that we were generating 10 years ago and the amount of data that we are generating today, it's not even close. It's not even a competition. Let alone competition. You cannot even say it's a minutest of fraction. That is the kind of exponential growth that data has seen, or the data generation has seen, right? So Databricks will give you a collaborative workspace, right, where multiple people can work together. So when I say multiple people, I'm referring to their job roles, right? So you have essentially multiple types of job roles when it comes to managing data or working with data, right? One is your database administrator. That is one role. Then you have a data engineer. You have a data analyst, right? And you have a data scientist. So these are all different data related roles. When it comes to Databricks, it it is useful for data analysts also, it is used for data scientists also, and it is useful for data engineers also, right? So it's a collaborative environment where all of these people are going to work together, right, to write their code, to execute their code efficiently. All right. And Databricks, it integrates deeply with Azure. That is something that we are going to discover, right? So how it works, right? It works by integrating with Azure, and whatever resources Databricks will need will be provisioned by Microsoft Azure in the backend, hence the managed service. It connects very easily to various Azure services, right? The data lake storage that we talk about, that is the basic storage service in Azure. The Synapse Analytics, right? Again, which is the data warehousing solution within Azure. The Azure machine learning, that is to create ML workloads within Azure, right? So how Databricks works is, it leverages these Spark's or Apache Spark's distributed processing capabilities. All right. To basically manage, right, large data sets across multiple machines. Now, what is this multiple machines that we are talking about? Right? What are these multiple machines that we're talking about? So within Spark, right, and it's a property of Spark, not Databricks. All right. When you talk about Spark, and I'm talking about Apache Spark here, right? Because nowadays so many tools, so many technologies are coming in, right? Recently I got to know a few weeks ago that GitHub has launched something called as GitHub Spark. Right? Now people are going to create these microservices on GitHub, right? And it's an AI assistant that is going to help you. So when I say Spark, don't get confused, I am talking about the Apache Spark. Clear? Now when you start working with Apache Spark, right? How does it process your data? So what is this compute that we are talking about? Now, the Spark architecture is very simple, right? It's very simple, and I'll explain it to you, and you will understand it in 2 minutes, right? There is going to be a main controller, right? Or the master, and there are going to be individual workers. These are called as slaves. All right. Now, this master slave architecture basically signifies that the master will give tasks along with instructions, along with data, right? And it will give task, instructions, and data to all of these slaves. And these slaves are then going to do all the heavy lifting and the hard work, right? That is how it is defined in general. But when there are thousands of slaves, will the master go to each slave and make them do work? Or will the master get to know the status of individual slaves on his own? The master will not do that, right? It's too much work for him. Therefore, what the master does is employs somebody else to do this task. All right. And who's this somebody else? This is nothing but the cluster manager. So cluster manager are various cluster managers are available. You have Yarn, which is a Hadoop native cluster manager, which is, the full form for Yarn is your yet another resource negotiator, right? So that is Yarn. Uh, any other cluster manager that you know of, something that is used to manage nodes, right? Anyone wants to take a guess? Any cluster manager that you know of? It's very commonly, very prominently being used in software development industry today. It is something that is, a prerequisite for any software development role which is there in the market today.
Kubernetes.
Absolutely correct. Kubernetes, right? So Kubernetes is also a cluster manager. Then you have the standalone. Now, these are all different cluster managers which are available that you can use within your Spark architecture, right? The job of the cluster manager is very simple. The job of the cluster manager is to keep an eye on all of these slaves. Now, in general, they are not called as slaves. Please don't call them slaves. I just call them, to explain to you the master slave architecture that you are used to see. These are called as nodes. These are individual nodes. We call them nodes. All right. And all these nodes together is called as a cluster. All right. So a single compute, these are nothing but your virtual machines. So they will have some storage, they will have some memory, they will have some CPU. Yes. So you can think of these nodes as individual Linux machines that get created. When we create them in Databricks, you will see that individual Linux virtual machines are getting created. All right. So these nodes will have configurations like 4 cores CPU or virtual CPU and 16 GB RAM, right? So something like this you will see for each node. So this is going to be the size of each node. Now, depending on the amount of data that you have, depending on the complexity of data processing that you are doing, right? You are going to define the number of nodes, right? It could be a single node also, it could be 5 nodes also, it could be thousands of nodes also, and there is essentially no upper limit over here when it comes to nodes, right? So the cluster manager, which is by default within Apache Spark, is the standalone cluster manager, right? So standalone cluster manager is the default cluster manager that you have. The job of the cluster manager is very simple. It keeps an eye on all these individual virtual machines. It will see if any virtual machine is sitting idle. If the virtual machine is sitting idle, it will tell master that I have an idle machine. Give me another task. So what master will do is it will take the individual data and break it down into smaller pieces, many smaller pieces. So if you have, let's say, 1 TB of data, you can, break it into thousands of smaller pieces, right? And what the master will do is now it will send an individual unit of data, right? Like one, and along with the code, right? So what data processing that I have to do on this data, right? Obviously, you will be performing some transformations on the data. So what transformation is there? And the data, the small chunk of data, the master will share with the cluster manager, which will then give it to the node, and the node will start working. If any of these virtual machine fails, right, stops working, the cluster manager will inform the master, and whatever data was shared here will be shared again, and now the cluster manager will assign it to somebody else. So basically, you have a pool of various nodes, and the cluster manager will keep an eye on all of these nodes, right? And the master is where, the data gets broken down, and the data along with the processing logic has is transferred to the cluster, to the individual nodes, and these individual nodes will have individual output, right? So this will be output 1, output 2, output 3, output 4, let's say. So at the end, all of these individual outputs are combined: output 1, output 2, output 3, output 4. So you add all of them and you get the final data, right, that you had, with all of whatever processing that was required being completed. So this is a high level picture that I have given you, right? Inside this, there is a lot of complexity that we'll try to understand, right? What is Spark core? What is Spark context? What is Spark session? What are Spark APIs? What is a high level API? What is a low level API, right? What is API in general? Now, whatever Spark architecture that you see here, right? As a programmer, as a developer, you need to talk to it. Yes or no? You will require some knowledge to talk to this cluster, to talk to the master, to give master, the code along with the data and everything, right? And what transformation logic has to be given, all of that information you will give. So how will you talk? You talk through APIs, right? So we have these Spark APIs. The APIs are divided into two parts. All right. APIs are divided into two parts. One is high level and the other one is low level. Now, what is the difference between a high level Spark API and a low level Spark API? Now, and trust me, you won't get it right if you do not know it already, because we are, with the word high, we'll assume that it will be more complex. It will require more, information. But it's absolutely opposite. Low level APIs like RDDs, resilient distributed data set. This also is something that we'll try to understand within the class. High level APIs like PySpark, Scala, R. These are high level API. So these are different languages that you use to talk to the Spark architecture. So we will be using PySpark in general to talk to the Spark architecture. The low level APIs are very complex. All right. We call them low because we are trying to signify that they require you to go into the most interiors of the architecture and define everything on your own. All right. Whereas high level APIs will mean that you are defining the core logic and the code, and that is fine. Whatever else is required to talk to the interiors of the architecture, that my Spark will take care of. All right. So, for example, people love car, right? People love car, but there are two types of fans when it comes to loving cars. One is a technical fan, right? The other one is the feature fan. Yes or no? Some of you would be fans of a car based on its features, and some of you would love a car based on its technicalities, right? So a feature loving fan would be somebody who would want or who would describe a car like, oh, it has got a good shape, it's the looks are really beautiful, the color is really good, right? It has got ventilated seats, um, you know the music system is really good. So these are people who love the feature. And when it comes to the technical people, right, they'll talk about engine, they'll talk about transmission, they'll talk about how much torque is there, what is the engine capacity, what are the braking mechanisms in the car, right, which a general person would not be able to relate to, right? So technical, you can think of it like low level, right? And people who define the car from outside and still can define it, it is the high level, right? So now you understand the difference between the low level and the high level. So with low level APIs, these are very complex languages. RDDs are very difficult to work with, all right, because there you need to interact with a lot of interiors of the Spark. Whereas high level APIs, PySpark, Scala, you just define your logic, you define the data that you want to work on, and you can continue. It will manage everything in the backend. So this is the Spark architecture in general. There's more to it, but now at least you have an idea of how this works, right? Why did we come to this distributed computing? Why? So I'll explain it to you. Earlier, back in the day, we started with a monolithic system. We started with a monolithic system in the beginning, and this system was a single large machine, very large machine, right? And here we had something called as vertical scaling, right? Now, what is vertical scaling? Vertical scaling means increasing the capacity of the existing resource. You increase the capacity. That is vertical scaling. When I say horizontal scaling, there I'm saying that I had one machine. Instead of increasing its capacity, I add another machine, right? So this is horizontal scaling. And this is the difference between the monolithic computing and the distributed computing. In monolithic approach, I will have a very large single compute resource that will process my data. And in the distributed computing, I'll say I am not going to have a single large machine, but I'll have individual smaller machine. Power of unity, right? So power of unity will always be bigger than the power of a single unit, correct? So you have a lot of phrases also around that. That if multiple people come together, it's very hard to defeat them, right? And a single person, however big it is, uh, it's bound to get defeated. And that is where distributed computing defeated this monolithic computing. Because first of all, there is a limit to this vertical scaling here. You cannot scale indefinitely. If I have a machine, I can scale it. Obviously, I can increase the size. I can keep on increasing and I can reach a specific point, but beyond that, it might not be possible. Correct? And monolithic computing also offer a single point of fault. All right. This means if there is any fault in this machine, the machine goes. Whereas in the distributed computing, if there is a fault in a single machine, the rest of the machines will still work and your data will get processed. Your data processing will not stop. So there is a very high, we call it fault tolerance in my distributed computing. So that is the benefit that we have with distributed computing. All right. Yeah. So we were talking about what is this Databricks, right? So this is what we are going to cover, how this data is processed using Apache Spark. You know, what is the difference between Databricks and PySpark? See, PySpark is the language that you're going to use to interact with the Spark architecture. All right. Databricks is a platform that uses the Spark architecture along with other services also for our data processing needs or big data analytics needs. All right. Apart from this, Databricks will have a cluster manager, as I told you. There is notebooks that you'll be creating here, your Python notebooks, Jupyter notebooks you would have seen, right? It provides a notebook based interface for coding, where multiple team members can share their code, work together. So it is where you can have a shared collaboration among various teams. It has a lot of built-in security and compliance abilities also because it runs on Azure, right? So therefore Databricks offers enterprise grade security. It gives you encryption, it gives you compliance, right? Industry regulations can be followed here. And with something like Microsoft Entra ID, that was previously known as your Azure Active Directory. I'm sure most of you would have heard about it, right? For authentication and identity management, and then various other Microsoft Purview integration and all. So that has added a lot of security, governance, and compliance onto the data that you're going to work with in Databricks. Now, it has support for machine learning and AI based integration also, right? Uh, but our focus throughout this course will be mostly, on data engineering based workloads, right? So it integrates very well with Azure, right? It offers a unified data processing, analytics, everything under one roof. All right. So people don't have to switch between different tools. Everything is doable, everything is accessible in the single platform. All right. And Databricks also includes something called as a Delta Lake. Now, as of now, you do not. I'm sure most of you will not understand what Data Lake is. So it will be silly to explain you what Delta Lake is because it is an upgrade of Data Lake. So, but it's a feature. It's a very strong feature. It's some storage layer, right? Delta Lake that ensures very fast query. All right. Also, it implements ACID compliance, right? Atomicity, consistency, isolation, durability. So it supports ACID transactions, which was not present in my data lake, right? That is something which Delta Lake offers me over and above my data lake, right? It offers time travel. So when I'm, within Delta Lake, you generally create tables in the Parquet format, and those tables will allow you time traveling, right? It's a very strong feature where you do transformations on the data, but at the same time, all the versions of your data are getting stored somewhere. All right. So they're storing a copy of all of your data. Now, what happens here is, let's say you transform data once, you transform data twice, you did it thrice. When I say thrice, it's a subsequent step. All right. So you did a particular transformation, you got a result. You did some other transformation, you get some other result, and then on that result, you did some other transformation. Three series of transformations you did on the data. Now, what if I want to go back to the data that I received after the first transformation? In general, it is not possible. But with Delta Lake, this is possible. And this feature is called as time travel. So we'll see that also in the course. All right. So it's being used across various industries. Databricks, right? It's widely adopted across various industries, right? Due to obviously the ability to process very large amounts of data sets and generate some actionable insights from those data sets. Also, it's being used in finance sector, right? Financial institutions want to deal with this vast amounts of transactional data that they're getting, and they want to implement machine learning algorithms to identify fraud detection, right? To create a fraud detection system, do real-time analysis of the data. So Databricks is a unified platform that will allow them to do machine learning, workloads also, and then um, for you to analyze the streaming data that you're getting, the real-time data that you're getting, um, try and work like a data warehousing solution for your data also. So all of that it can do, right? Similarly, in healthcare, it is being used. In retail, it is being used, right? So everywhere, data bricks is something which is being used. So why learn Databricks, right? Now, the importance of big data processing, and obviously analytics also, in today's tech landscape is huge. All right. The modern world is sitting on big data. Big data is everything, right? I hope you understand the difference between normal data and big data. And it's very, very simple, right? If you have, just give me a second. Yeah. So if you have a pinch of sand in your hands and I ask you to count it, that is normal big data, normal data, which is, somewhat difficult, just a pinch. And the chances are that you'll be able to count the number of particles in that pinch of sand that I've given you, right? That is your normal data. Big data is if I give you the entire beach and I'm asking you to count the sand particles. That is big data, all right? Which is obviously you cannot process it. The human mind cannot process it. A simple computer may not be able to process it. Multiple computers also may not be able to process it. And you need a specific architecture and a method to process that huge amount of data that you have, right? Now, as I said, the organizations today, across industries, they're relying on these data, right? Whatever data we are generating, the organizations are relying on these data to, make decisions. They want to predict consumer behavior. They want to optimize their operations, right? They want to develop AI models. Now, AI models will also need data to learn, right? So data analysis has become critical asset in business strategy today. And therefore, every organization is using it, is making use of it, right? And with the explosion of connected devices, sensors, digital transactions, the sheer volume, velocity, variety of data generated today, right, is unprecedented. So your traditional systems, they would fail to process this data set, right? You'll get very slow insights, high costs, limited scalability. And this is where this big data processing platform like Databricks comes in. And that is why you have to learn Databricks, all right, which offers a very optimized solution for high performance computing, real time analytics, large scale automations. All of that you can do with Databricks. All right. So Databricks, cloud based cloud based data analytics platform that enables businesses to efficiently process big data, right? uh, Benefits you already know. If you want to compare it, right, today, uh, Databricks to, let's say, Hadoop and Spark, right? How do I compare it? When you talk about Hadoop, right? How many of you heard of Hadoop? Just let me know in the chat window. As a big data processing engine, how many of you heard of Hadoop, the MapReduce method within Hadoop, MapReduce framework within Hadoop? How many of you heard of it? A few? Yes, absolutely. So you compare Hadoop with Spark and then Databricks. Hadoop used to work on disk. It used to write intermediate or intermittent data, I would say, or intermediate data, right, onto the disk storage, right? That made the entire process slow. That is what Apache Spark improved by introducing the concept of in-memory processing. I'm not going to write or read data from disk. I'm going to read and write data into the memory, which is much, much, much more faster, right? That is why when, in certain cases, and you'll find it in several places, which is actually not true, but everybody's using the same slang. And the slang is that Spark is 100 times faster than Hadoop. Now, for a particular situation in a particular use case, that may have worked. It's not something which is general, but in general, Spark is 60, 70, 80% times, or times, I would say 50, 60 times faster than Hadoop. And Databricks also uses the in-memory processing, but it is more optimized. It is much more faster today. All right. That is why people want to work with Databricks. When it comes to scalability, Hadoop required manual scaling, right? Manual resource allocation. Spark offered, some level of uh, moderate, auto scaling, but it was not available everywhere, right? It all depends on the tool where you're using Spark. Whereas in Databricks, you have dynamic scaling, auto scaling, rule-based scaling, everything is there, right? Hadoop was very complex. Writing, code in Hadoop was very complex. uh, Apache Spark also requires writing code, right? PySpark code, Scala code, Java code, R code. But Databricks, it in some cases gives you a very low code, user friendly solution. All right. Cloud integration of Hadoop is limited. Cloud integration of Apache Spark through various services is there. All right. Whereas Databricks is an Azure native support service. All right. Azure Databricks is an Azure based service itself. So that is why, you know, uh, Databricks is building upon Spark's speed and efficiency, and also eliminating Hadoop's dependency on complex disk-based storage systems, right? So that makes big data processing more seamless and cost-effective with Databricks, right? So Databricks fits into the Azure data ecosystem, right? It connects with Data Lake, connects with Synapse, connects with Power BI, connects with Data Factory. And if I touch upon the job opportunities, all right. Uh, so the demand for data engineers and big data professionals has surged in recent years, right? There are various studies available, let's say that's going to, grow with, I think 28, 30% is what I remember of CAGR annually. And I'm talking about uh, the jobs which are available in the market, right? And the entire ecosystem also. The entire data engineering ecosystem in India is growing at around 28 to 30%, right? Now, more and more companies and organizations today want to work with their data, right? And they're looking for good data engineers. They're looking for good data analysts also, right, to analyze this data. But what data will data analyst analyze if the data has not been cleaned and transformed, right? So without data engineers, data analysts are useless, data scientists are useless. They all depend on data engineers, correct? To get a structured data for their analysis or for their training, right? So the rise of AI today, right? It requires vast amounts of structured data. The expansion of cloud computing, that also makes data storage and processing, more scalable. The need for real-time analytics everywhere in almost all industries are today wanting real-time analytics, not batch processing. They want stream processing, right? So, you know, professionals who are looking to enter the big data and analytics field can go ahead and explore several careers, right? As I said, data engineer. They'll be designing and maintaining data pipelines, ensuring efficient data flow for analytics and AI models. And skills are very simple. You need to know SQL, you need to know a bit of Python, right? And then you need to know cloud platforms such as Azure, AWS, because most of the organizations are today switching, they're migrating to cloud, right? Nobody wants to have an on-premises data center today. It's very not cost effective, right? Moving to cloud is cost effective. And then the kind of features and the services that cloud service providers are giving you today, right? That also makes it very lucrative for organization to switch to cloud, right? Uh, Apart from that, the salaries and everything, right? In India, data engineers earn somewhere around 8 lakhs to 30 lakhs, depending on the obviously experience and expertise. I cannot give you an exact number that if you're entering as a fresher, this is what you're going to get. I cannot promise you that. But the kind of skills that you have, with the kind of hands-on experience that you have, yes, obviously you'll make a great case for yourself while interviewing and while trying to get a job in field of data engineering. All right. And there is one more thing as to why you should go ahead and learn Hadoop. No, sorry, Databricks, right? Now, 60% of or 60% or above of the Fortune 500 companies today, they're using Databricks in some way. Databricks is a multi-cloud solution. If you understand Databricks, if you're able to work with Databricks, Databricks will work exactly how it works in Azure, in AWS also, in GCP also. So it does not matter what cloud the company is working with, all right, or what cloud the company has its infrastructure on. As long as you know Databricks, you can go ahead and work with a company who has, which is having all of its resources in Azure, also with a company that is having its resources on AWS. Then in that case, you just need to know more about the AWS services because you already know the capabilities of Databricks, right? How it's going to work. So you don't have to change your knowledge around Databricks. All you have to do is change your knowledge around the cloud services. And cloud services, when working with Databricks, is not a very huge part. The majority of the portion is on Databricks itself. Clear? So if you're looking to switch to data engineering on Azure, right? Uh, then obviously you're going to find increased job opportunities across industries because Azure currently is the fastest growing cloud. All right. There are several studies that suggest that almost 85% of job openings today mention Azure as a required skill, right? In data engineering, they will mention Azure or Azure specific services. All right. So data engineers are essential across multiple sectors: finance, healthcare, retail, tech companies. I've told you everything about that. And businesses, they rely on structured data to create these pipelines, to create, to get analysis and everything, right? And good data engineers are highly sought after today. So if you are demonstrating an expertise in big data processing, especially with Databricks, right, uh, you can significantly expand your job prospects, across industries. So I'll just quickly walk you through, 1 second, the what we'll cover in this course, right? And then maybe we can take a few questions. But don't worry, tomorrow is also a demo session. Day after tomorrow is also a demo session. So I would suggest everybody to sit here in those sessions at least, and we can have a discussion. Tomorrow also we can have, we can take up your questions day after tomorrow also, and today also we'll take it. All right. So what are we going to essentially cover in this course? You would, I think, already have the details, right? So it'll start with the basics of Azure. Let me write this, right? So we'll start with the basics of Azure, right? We'll move on towards, what is cloud computing, what are Azure services, what is storage, what is networking, what is security and identity management, and then we'll move on to discussion on how do you create Databricks on Azure, right? Because I need to show you how you actually go to the Azure portal and create a Databricks environment, right? That is also essential. Then we'll come up to setting up the Databricks workspace itself, right? So this is where, we'll see how you create the workspace, how you configure it, how do you set up your Azure storage and Databricks integration, right? How do you connect your Databricks to your data lake storage? Then we'll try to work with the data where, that is going to be the module 3, that is working with data, right? So this is where we'll see reading and writing data from various sources, trying to do analysis and transformation on the data using SQL. All of that we'll do in this particular section. Then we'll move to the next module, that is module 4, where we'll talk about the advanced data architectures in Databricks. We'll see the medallion architecture in Databricks. We'll see the data lakehouse, the Delta Lake, all those things. Then we'll move towards module 5, that talks about visualization and creation of dashboards using Databricks. How does it integrate with Power BI? That also we'll see. We'll see ADLS and Databricks integration. How do you mount ADLS on top of Databricks? We'll see Hive Metastore, how you create databases, how you create tables and views within the Hive Metastore, right? We'll see how you can, stream data and do streaming data analysis using Databricks. We'll see how you can create pipelines using Delta Live tables within Databricks. And we'll see, Databricks jobs also. We'll see source control, CI/CD with Databricks. And then finally, we'll talk more about the governance part, where we'll see the access control within Databricks. And we'll have the final project discussion. So all the core capabilities of Databricks we are going to cover, both theoretically and through demonstrations in the class, right? And I'll also be giving, wherever necessary, I'll be giving you practice problem statements with the data sets. Obviously, you have the data set, you have the problem statement. Now I'll leave it to you to do the implementation work. All right. So that is going to be the entire course structure. This is what we're going to cover. Tomorrow, we'll have a demo on basics of Azure. Day after tomorrow, we'll have a demo on Spark and Databricks. All right. So I want to cover both of them. Right. So day one, Azure only demonstration, and day two, of the demo, the day three it will be, right. If you count today as day one, then day three would be talking about Spark and going into the depth of Spark architecture, trying to understand how the data is processed, how the data is distributed, how the memory management is done. All of that we'll cover on day three. Is that clear to all of you? Yes or no?
So yes, do you
Yeah.
cover unit catalog here?
Yeah, I I think multiple people spoke at once. I could not.
Sorry,
Yeah,
Yes,
were you
yes.
covering Unity catalog?
the recording you're asking about,
No, no, classes.
the
Some,
classes will, yeah, the classes will be from 9:30 to 10:30 p.m.
I'm
late night
asking
class.
about the Unity catalog. Unity catalog is important part of data governance, right? So,
Yes, yes, Unity Catalog also will be working with the data governance and compliance part. That is also part of syllabus.
yeah, yeah, thank you.
Yeah.
I am Rishi, and I have one question actually. So,
Mhm.
Connectivity. Connectivity. Connectivity.
okay,
Wait.
Wait, I know that.
Wait, I'll just mute
yes.
them. Yeah.
So I was just
Mm.
wondering, like, so I heard something about the AI BI in the Databricks. Is that also the part of the course?
Uh, See, AI and BI. So BI we are going to cover to an extent. AI is not something that we are going to work with, extensively within Databricks. All right. Our focus will be mostly on data engineering solutions.
Okay. Okay. Thank you. Thank you.
Yeah.
Hello, Shreyas. I have two questions.
Mhm.
I want to know what is the prerequisite for this course? And the second question would be how much years of experience I can claim after completion of this course?
Yeah. So prerequisite is very simple. SQL, you should know. Uh, Somewhat data analysis using SQL, you should be able to understand, right? What is aggregates? What is, how do you do different type of joining and all. So all those things are important. Apart from that, uh, basic level of understanding to a basic to good level of understanding of Python is required. All right. If you do not know Python, we'll be sharing a Python tutorial with all of you, right? The basic Python tutorial. I have some resources available with me. So in the first week, when we are going through the basics of Azure, you can take out some 20-30 minutes a day and go through those basic Python videos, right? When it comes to PySpark, right, in general, the library that we're going to use, that we'll be trying to cover from the scratch in the class, right? And PySpark, you'll learn end to end within the class itself. So you don't have to worry about it, but have some understanding of Python.
Okay, yeah, sure.
Yeah. So will be sharing. So whoever registers for the course, we'll be sharing the Python tutorial to all of them.
Okay.
I have one
And
question. Yeah,
and
go on.
how,
Yeah.
Sorry.
yeah, sorry. And there was one more question.
Yeah.
How much years of experience can we show with after completion of this course?
See, after completion of this course on Databricks, you can claim anywhere from 2 to 3 years of experience. That is the kind of depth that we are going to get into. And
Okay.
obviously, at every given point, there will be a lot of hands-on. Uh, Whatever we do in the class, you'll have to perform it on your machines, and on top of that, also with the projects, with the regular exercises, you'll have a really good hands-on experience on Databricks.
Okay, okay, sure. Thank you.
Yeah,
Hi, Shreyas. I have a question.
yeah, yeah. Hi,
So,
Om.
based on this PySpark and Databricks, can anybody switch into a data engineering role if somebody has more than 8+ year of experience?
So you're asking with 8+ years of experience and using PySpark and Databricks, can you switch into data engineering? Yes, obviously you can, right? These are uh, basically these are tools that data engineers use, right? Obviously, you'll have to build more expertise on top of it when it comes to, let's say you want to become an Azure data engineer, right? Then having understanding of Databricks is important because you'll get a lot of roles where Databricks would be a mandatory requirement. But on top of that, you also need to have some understanding of tools like Synapse, Data Factory, uh, Stream Analytics Service, all these different various tools on Azure, right? So that basic understanding I will give you within the class itself. What is Synapse? Why is it used? What all you can do? What is Data Factory? Why is it used? What all you can do, right? So you will have that level of understanding, but then again, you need to build more on top of the other services. All right. But Databricks
Mhm.
and PySpark on their own are, extremely good skills to have, right? They have nothing to do, I mean, obviously it all relates together, but then you can learn them separately also.
So, like, do you have any comprehensive course for complete data engineering which cover all the required tools and technologies?
Yeah, we are conducting, our data engineering courses where we cover everything, uh, all these services. That will start, with Azure, going on to data lakes, going on to Cosmos DB, then talking about Synapse, Data Factory, Steam Analytics, Databricks, all those things. You can get in touch with the backend team to know more about it.
Okay, yeah.
Yeah. All right. So I think it's pretty late today, but don't worry. We have another 2 days to connect, right? So we'll have demo session tomorrow also and day after tomorrow also. And I request everybody to please be a part of demo session, right? You'll get to understand as to how we are going to, take on the concepts in the class. That'll give you a very better understanding. All right. Please do
Shreyas,
attend the yeah.
uh, yeah. Can I ask you one question? Just last
Mm-hmm.
question.
Yeah. Go ahead.
So basically, I am from a testing background, and recently I have done my master's from UK, and
Mm-hmm.
there, as a dissertation, I have done my project in, of ETL. So I
Mm-hmm.
used Talent and end-to-end project I have done from setting up the database, data warehouse till Power BI. But yeah,
Mm-hmm.
it was like a basic project. Uh,
Yeah.
and now I'm trying to move on to this course with the data engineer.
Mhm.
So, I mean, what do you suggest me? Like, will it help me, or uh, I mean, uh, will I be able to, or what? I'm not sure.
All right, I understood your question.
Yeah.
See, uh, if you want to really get into data engineering, and since you have a background in ETL, right? You just said, so these services, they are very important. Uh, Databricks or other services also, right? They're very important. And if you want to build your career in data engineering, then these are must-know technologies for you, right? Databricks, PySpark, extensively being used, right?
Okay.
And your existing knowledge, right, that you have in ETL projects, right, whether it's a data pipelines that you created, right, data validation you would have done, you would have tested your pipeline, CI/CD integration of those pipelines also you would have done, right? So on top of that, Databricks and other Azure services also that we're going to discuss about, right, they're going to be very useful for you to transition completely into this data engineering role.
Okay, okay, yeah, because I was thinking like I'm new to cloud. I have never worked in cloud. So, yeah, but although I have an interest to get into this field, so mm,
All
just
right,
wanted,
you
yeah.
get in touch with the backend team. We'll
Okay.
discuss more on this.
Okay, sure, sure.
Yeah,
Thank you so much.
yeah,
Yeah.
yeah. Thank you. So
Sure. So
Eh,
last question from
yeah,
my
yeah, go
side.
ahead.
Uh,
Hmm.
Yeah, do we covered any data build tool DBT from here?
Do we cover any?
DBT, data builder tool.
Uh, Not specifically.
Okay.
Specifically here. Yeah.
Okay. You're not touching any DBT or 510, right? 510
No, no,
like
no.
Okay. Okay. Got it. Thank you.
Yeah, yeah. See, it's not a native part of Azure Databricks, right?
Puna, ki-
Yeah.
Yes,
All
I
right.
understood, but the market is so requesting these all tools. Yeah, thanks.
Yeah.
Shreyas, I have one question. So, how much of the Python and the SQL knowledge that you do need to get this Databricks?
See, for any data engineering role, SQL is the most essential part from what my experience is, right? SQL is a must know thing, must have skill in your skill set. uh, and when you're talking about SQL, right, I would say that it's not something which will take 1 month or 2 months for you to master it, right? Even if you sit for 5 days, 10 days, you can master SQL, right? So therefore a good understanding of SQL is something which is required. When it comes to Python, eventually, to become a great data engineer, you will have to master Python, right? But for this course, to understand, right, the concepts and the things, you should have a basic understanding of Python. All right. But yes, as I said, the sky is the limit. And if you want to reach the sky, then you have to become a master at Python eventually, right? But having that, master knowledge in Python is not something which is required for you to complete this course, right?
Got this.
Because
Okay.
PySpark will be covering end to end in general.
Okay. So while learning PySpark, we'll be able to learn Python. Is that what you're suggesting?
Uh, Not exactly. Python gives you a lot of different various features. PySpark generally, helps us to talk to the Spark architecture and work with our data transformation. So that part, I'll make sure that you understand. But rest of the Python, that you have to master yourself. Yes.
Got you. Thank you, Shreyas.
Yeah. All right. All right then. Thank you all. Please do join the session tomorrow. We'll have a discussion on Azure, and we'll try to see basic services in Azure. And day after tomorrow, we'll have a session on Spark and Databricks. All right. So we'll cover both of them.
Yeah,
So
sure.
thank you.
Sorry. Yeah,
Yeah.
what is the course cost? Any chance?
Course
You.
cost is rupees 12,000.
Yeah.
Oh, okay. Great.
Yeah.
We'll be sharing this today's class, right?
Yeah,
On
this
video.
this video will be posted on YouTube.
Okay.
Yeah. You can
Thank
go
you.
through this video on YouTube.
Yeah. And those who are interested to continue, please join the same meeting link tomorrow as well.
Sure.
Thank you.
All right. Thank you all. Thank you all.
Thank you.
I hope to see you guys tomorrow. Thank you for your time, everyone.
Yeah,
Thank you. Thank you.
thank you.